Hello everyone. So let's start today's session with a particular CCN program from part A. So before I start the today's session, I will tell you the brief about my previous two sessions what I have recorded. So in the previous two sessions I have told clearly about what is computer network, what are the different way of representing the sensor node, or how to create the wire and wireless network, what are the architectural features of the protocol stacks, the difference between OSI and the TCP module, the difference between the simulator tool and the emulator, and what are the different operations done by each layer of the protocols. And in my second video, I have told clearly about a particular tool, that is Network Simulator version 2, NS2 tool. So where you can see the complete execution of the program in general view. I have told clearly in terms of how to open the terminal window, from where you can create your own directory, how to access your directory, how to edit the program, how to write your own programs, what are the commands you can give for executing the programs, and how we can vary the parameters and analyze the changes with respect to the varied parameters, and how finally you can execute your animator file. So I have told complete details of all the programs, and also a clear steps has been given for writing your own programs also. Okay, with all those fundamentals you have to start executing from program 1. So we'll see what is our first program according to the syllabus. So as per the syllabus, you have part A and part 2, part B. In part A, the programs are like simulation, few experiments using any one of the given tool like network simulator tool, NS2 or NS3, or you can go with a NetSim, QualNet, like that. But we are using NS2 because of its simplicity. And part B programs are simulation using C++ code. Okay, so let's start in today's session. The first program, that is implement a point-to-point network with 4 nodes and create a duplex link between them. Okay, so here what you are supposed to do is you have to implement a 4 node network. So here this is an example of wired LAN network, this is an example of wire network where you are going to create a 4 node, and among all the 4 nodes you have to create a duplex link. Why we have to select the duplex links, and what are the different protocols accessibility, how I can implement those layering concept in NS2 architecture, I have told in the previous session. Please go through it carefully. Okay, so once the network is created and duplex links has been assigned, next we have to vary some of the parameters of that particular duplex link in terms of queue size and then bandwidth. Then we have to check what is the amount of packet dropped or it may be sent. So this is about our first experiment. Okay, so let's start from the first step, the program execution. So the first step is open the terminal window. For that the command is Ctrl Alt T. So now here you have to give a particular path, you have to select where you can store your programs. So now I have already stored in some folder on my desktop. So I will give a path, I will change the particular path to my desktop so that I can access all the programs over there. And in that I have stored the programs in some file. So now I will be opening an editor window. So for that command is gedit space file name dot tcl. Then you can give ampersand symbol whenever you want to view a parallel window between terminal window and the editor window. Whenever you want to view the parallelly both the window, some error comes. So every time opening closing may you will held with some confusion. So parallelly you can see what is the error, and in editor window you can debug the error easily. So for such case you can use this ampersand window. Okay, so in order to open the editor window, the command given is gedit n1.tcl, then enter. Then your editor window will open where I have already stored the program. Generally here you have to type when you open first time, the file will be empty, you have to type the program. Okay, so as I told, the first program, it's with respect to creating the 4 nodes and providing duplex link between all the 4 nodes. How it has been oriented, how you need to arrange the 4 nodes, that is not mentioned clearly here, so it is left to the designer. Okay, so one particular session I have taken, particular representations I am taken here considered, accordingly I will have implemented the program. Okay, so according to the steps what we have to follow for writing the program is, the first step is to create the simulator object. Okay, first step is to create your own simulator object with some name. So the name what I have selected for creating a simulator is my NS. This is a name what you can give for your program. This may be anything, you can give your own name also or the program name also, it's left to you. Okay, this is an object name for my new simulator. Okay, then the second step is to create some of the files which is required in order to generate my trace file and the animator file. As I said, the output will be shown in terms of 2 output files, out.tr and out.nam. So one is, in order to view the statistical result, I will be using out.tr folder, and in order to see the pictorial representation of the experiment what you have done, how the network has been structured, so that you can see animator file, network animator, NAM is nothing but network animator. So out.nam, this W represents something to be written. Whenever you are executing the program, some result should be written in that particular file. Initially it is empty. Once you start executing, the respected relevant data with respect to times, it will be stored in the respective files. Okay, so in order to trace both the files with respect to a time, I have to create, or I need to give another 2 command. One is for trace all and another one is for nam trace all. Okay, these are the basic functions which I need to create for all the programs from part A. Next, now I have to initialize my TCP/IP protocol. As I know, the TCP protocol has 5 layering structure. The lower 3 layer is nothing but physical layer, data link layer and network layer. So whenever you create a node, whenever you say create a node, the syntax for that creating the node is set the node name. Generally the node name will be given in terms of N0, N1, N2, N3, where these nodes belongs to my object, my simulator object with the name my NS, and I will be calling it as node. Okay, so whenever you say create a node, that ensures that the lower 3 layer of my TCP/IP protocol has been initialized. Okay, the lower 3 layers is initialized. The syntax is same for all the 4 nodes. So like how I have created set N0 my NS node. Similarly I have done for all the rest of the nodes N1, N2, N3. Okay, so now according to the given statement of the program, now 4 node has been declared. That means the lower 3 layer of my TCP/IP protocols are set. So now I need to label which nodes I want to make it as a TCP source, which node I will be calling it as UDP source. So in this program they have not mentioned clearly whether I can go with the TCP only or UDP only or combining both. So it's left to the designer. So in order to make the program to be simple for first 2 programs, because first two programs are almost same. So I will have considered both type of the packet transmission, TCP as well as UDP. So here I have selected node N0 has TCP source and node N1 has UDP source, and I will be calling N2 as my router and N3 becomes the receiver. Okay. So for accordingly I have labeled those nodes. Okay. So $N0 label that particular node has TCP source. So this is mainly required in order to generate a proper network animator picture. So we'll see whenever we'll see execute the NAM file, the picture will be represented, a pictorial representation like a video. In order to differentiate between the nodes, we have to label. So for that purpose, this labeling is required. Then in this program, as we are using two different types of the protocols like TCP packets as well as the UDP packets, I have to differentiate in terms of the coloring. So how to color it? How I can differentiate in terms of color for those two packets? So for that I will be using these two statements. So the first statement indicates of my object for first protocol transmission TCP packet, the color assigned is blue. For the second packet, let it take red. Like that we have few inbuilt color for each type of packet transmission with the network simulator tool. Among those you can access any colors. Okay. So now till now we have created the NAM file, trace file. We have created the node. In that node I have told which are the source node and which are the receiver node and which one is the router, and color differentiation also given. So now I need to tell how the orientation and how to create the duplex link between the node. So for that the command is object name. First I need to give object name, then I will be telling which type of link you are using, between which node to which node, and what is the parameter I need to consider for that particular node, and drop tail. Drop tail is my queue type I am accessing for this particular example. Okay. So now I will be creating a link between N0 to N2 with the bandwidth of 2 MB and the propagation delay of 10 millisecond. Then next link is between N1 to N2 with the same bandwidth and same propagation delay. Let's give for first session, we'll give all the parameters as constant and we'll see what is our drop packet. Is there any chances of packet to be dropped whenever all the parameters has been kept? If not, then I will vary these data and we'll do the changes. Okay. Then third is the duplex link between N2 to N3 with the same parameter. Okay. Then as the type of the queue is drop tail, I have to give some limit for the queue. That is for the channel N2 to N3. For the duplex link N2 to N3, I have given a queue limit of 40 packets. Okay. So now duplex links has been done. Now how the orientation, how they are placed in the network. So for that the node position should be given, which is mainly required for my network animator file. Okay. So for that the duplex link, the command is object simulator object. Then I will be selecting what is the duplex link, how the N node, the node N2, how it is placed with respect to N0, how it is oriented, orient and the type of orient. Here I have two tabs mainly, right and left. In that right and left, again up and down. So depending upon these combinations, you can give the orientation between the two nodes. Okay. So now see here, for first line, N2 is oriented right down with respect to N0. Okay. So when you see the second line, the node N2 is oriented just right with respect to N1, and the node N3 is the node N2 is oriented right up with respect to N1, and the node N3 is oriented with respect to N2 just right. Okay, just nothing but it's a straight line. N2 to N3 is straight line, N2 is the intermediate here, N2 to N0 up, and N2 to N1 it will be down. So this is just a orientation. Okay, so now after the node has been created, the link is given, and lower 3 layer of TCP protocol has been designed, but still we cannot transmit the packet because I have to design completely my stack layer of TCP/IP protocol. Till now only 3 layers has been updated. So now I have to give what are the transport agent protocols and what are the application layer agents or the traffic I can access in order to send the packets. Okay. So now coming to the transport layer, where I can use two different types of protocols. Many different types are there. You will study in detail in the theory. But here according to the programs, we are selected only two types, UDP agent and then TCP agent of transport layer. Okay. So now I have to say UDP agent relevant all the details for which node I have to attach, and at the receiver side what I can how I can access, and I will be calling that in terms of a group, a particular class. Okay. So now set UDP agent of new, this is just a name. Here you can place anything, UDP1, UDP2, UDP3 or some particular other name you can access with this. Okay. But here what you are writing, this is my protocol which is belongs to my transport layer. So set UDP new agent of type UDP. Okay. So I will be selecting N0 node has my UDP protocols. Okay. Hence UDP should be attached to N1. So next first I will declare the agent, then I will attach that agent to particular node. Okay. So my object, the UDP agent is attached to the node N1. Okay. Similarly, this is at the transmitter. If N1 becomes the transmitter for UDP packets, at the receiver I will be calling as a null. But I have only one receiver, that is the node N3. Hence, first I will declare the null agent. I will declare the null agent with respect to this syntax. Then null is attached to node N3. Okay. And I will call this UDP and null to connect each other. A logical link should be provided between UDP and null, and that will be calling as one of the class. Okay. So now similarly you have to create a transport layer agent with respect to TCP. Okay. First declare the TCP agent, then TCP protocol is transmitted through a node N0. Hence, I will attach TCP to N0. Then I have to select at the receiver node has a sink. Hence, I have to declare a TCP sink node. I have to declare a TCP sink node, and that is attached to my node N3. Then I have to provide a logical link between this TCP and the sink, and the command for that is object name myns connect my TCP to sink. That means you are just linking your node N3 to N0. Okay. And I will call that particular transmission of this particular agent has another class. So this will be considered as a class 1 and this is considered as a class 2. Okay. So till this UDP and TCP. So this is nothing but my transport layer protocol. So now I need to provide a traffic. Means I have to declare what is my application layer protocols or the agents. Okay. In application layer also we can see a n number of agents, but here we have selected only 2. One is CBR agent traffic, and another one is FTP traffic type. So CBR agent should be placed upon this UDP agent, and FTP should be placed over a TCP connection. Okay, you cannot mix these two. CBR is with respect to a UDP agent, and FTP traffic is with respect to TCP connection. Okay, so now how to set a CBR application layer traffic. First, declare with respect to this command like new application of type traffic. That another inbuilt type is CBR. Okay, but this CBR is attached to what? UDP. Hence, attach. I will be calling, see the line, this line. So the CBR is attached to UDP. Okay. Similarly, I need to attach FTP over TCP. Okay. TCP and UDP has been declared. Now, application layer protocols or application layer traffic should be attached with respect to those transport layer protocols. Okay. So, now this tells at this time, line 75, it ensures that all the layer protocols has been done. Okay. Creating a node will initialize all the three lower layer of my TCP/IP protocol, and then agent declaration, UDP and TCP, and then application protocol declaration like CBR and FTP. Okay. So once the network has been created, duplex links has been given, and orientation is also configured. Now I have to start my simulation. So before you start the simulation, you should ensure that some event should be given. As we know, the network simulator tool is an event driven. It should be an event driven event. Hence, some event should be given. That means when the program should start, when the particular packet should start transmitting from the source through a router, and at what time it has to reach to the receiver, and when I need to stop the particular packet transmission. Okay. So in order to accomplish the task, a simulation start and stop event should be given for my program. So for that, how to access? First is my object name at, let's start 0.0.1. At point 1, I will be starting only CBR packet. Okay. Start CBR. Then at point 1.0 millisecond of time, I will start FTP transmission. Then at 4.0 FTP stop. At 4.5 CBR stop. So I have two types of packets, CBR and FTP. For both stop and start options has been given. And at that end, I have to tell when my complete simulation should stop. So here one point you need to remember, the completion, the finish time should be always greater than this stop time, because I cannot give like CBR stop is at 4.5 millisecond. I cannot give finish is also at 4.5 millisecond, because if you give 4.5, at that particular instant of time what the program has executed, those data cannot be written in my output file like out.tr and out.nam. So at last moment it will be empty. So in order to overcome with that, I have to give always the finish time is greater than the stop time. Okay. So now event is also given. Next I need to start my program execution. So before you start execution, some of the commands will give. So those commands are here. So execute nam file, particular command execute nam, then output file out.nam, then execute awk minus this f n1.awk out.tr. So this is a command where I can access my both the files to run, animator file and then statistics awk trace file. Okay, and here I have written a small procedure proc finish, which is going to mainly used in order to close the trace file and the num file once the program is finished. Okay. So finally after this finish, you just give the command as ns run. Okay. So once you execute this program, the result will be given in both the way, animator visualization, picture representation, and then statistical result also. So here one more program I will be invoking with this, that is n1.awk. So what is this n1.awk? Okay. So whenever you see the result has a pictorial representation, you will come to know how the packet is transmitted in the network and where the drop occurs. But we will not come to know that how many packets have received and how many packets have sent from the transmitter and how many packets has been dropped down. Okay. So in order to get all the statistical result about these parameters, I need to write a simple C program with respect to a file, that is out.tr. Okay. So I will be using the syntax of my output file. Accordingly, I will implement my n1.awk. Okay. So this is about the brief introduction about the program. So now I will open n1.awk and I will show what it has been written in that program. Then we will start with the program execution. So in order to open the AWK script, the command is gedit n1.awk and then ampersand symbol. Okay. Then enter. Your AWK script has been opened. So what we have written? So this is just a C program. This is just a C program. See, I have given a, okay, I will see first these lines here. You can see, yeah, line number 27, 28, just I have taken few lines from a trace file. In that file, I have 1000 together lines, out.tr. Out.tr contains n number of lines. Here I have selected only few in order to tell how and what way we are implementing AWK script. So when you see these lines, here the first represents what type of operations you are performing. Received packet, drop packet, in queue, out queue, like that. And at what time that particular operations is carried. This indicates time, and then it indicates from where to where, which node to which node the transmissions takes place, how the data transmissions takes place, and then this node, this position indicates what type of packet you are transmitting and what is the size of packets. Okay. So each line can be accessed with a symbol $. So $1, $2, $3, like that. So now in order to see this program, I will be accessing with respect to $1 and $5. That means $1 is nothing but R, D plus minus. Then $5 is nothing but 1, 2, 3, 4. That nothing but my destination node, my receiver. Okay, the receiver node. So at receiver node, what is the amount of packet received or drop, that we will check here. Okay. So this is my trace file format. Accordingly, I will access the information. Okay. Coming to AWK script, begin, flower symbol. Then I have declared two variables. One is for CBR packet, another one is for TCP packet. So both initially it is assigned to 0. So now check with the if. If the type of the data is D. D in the sense what? Drop packet. Okay. So this is written, this code is written in order to evaluate the amount of packet dropped. So if it is a drop packet, which type? If it is CBR type, then increment CBR packet by 1. If this is not CBR, let's assume the first column is drop, but the type of the packet is TCP. Then I have to select TCP packet should be incremented by 1. Okay. So this is the simplest program where I am accessing how many packets are dropped either from CBR or TCP. Wherever it is dropped, I will be just counting those drop packet and I will be printing those values. So number of CBR packet dropped and number of TCP packet dropped. Okay. So that means by accessing this AWK script, you are able to check a statistical result for the operation for the given set of parameters. Okay. So now, as I said, this n1.awk is accessed with respect to a main program through this particular execution command line. Okay. So now I will start execution. So before I start, as I told in the beginning, for your information, once again I will repeat, I have selected for all the duplex link, the bandwidth and the propagation delay are same. Bandwidth and propagation delay are same. If everything is same, there is no variation, then obviously I have to get my drop packet should be 0. Everything is accessed. Only when there between the link, when link between N2 to N3 is here, it is less than this. The duplex link bandwidth between N2 to N3, whenever this bandwidth is less compared to the previous two, then only I can see some of the packet drop. Okay. So first we'll execute this and then we'll see the result. So for execution, the command is ns space file name dot tcl. Again ampersand symbol, it's left to you. So when you see enter this, you will come to know that the number of CBR packets, see here these two lines, the number of CBR packet dropped is 0 and number of TCP packet dropped is also 0. So when you execute this, you will be getting an animator window where you can see a packet transmission between the node. So this is the orientation N0 with respect to N2. N2 is oriented right down, N2 is oriented with respect to N1 right up, N2 to N3 is just right. Okay. So this is the step size what you can vary and you can access the transmission, and this is the play button. Okay. And whatever the names I have labeled, so that will be accessed. This is TCP source, UDP source, router and the null, either sync or null. Okay. So now I will play and then I will just increase this. So when you increase, see as the time is running, initially only UDP packet, after 1.0, after 1 TCP packet is also transmitted. So for this particular instant, I cannot see any drop packet because the drop packet is 0. Okay. So just I will stop. We'll come back. Now I will go to my program. So again I will give the command as gedit n1.tcl ampersand. So it will open my editor window. So now I will change the command for bandwidth for the link N2 to N3. So here 2 is there. Now I will replace this less than 2. Less than 2, whatever values you will put, the drop packet increases, because you can see in traffic junctions from both the end, if more vehicles are coming and after the traffic junction the road is narrow, then all the vehicles cannot move. Some of the vehicles will struck and the traffic jam increases. The same case happens here also. Okay. So whatever the changes you will do, after that you have to save the program. Again go to terminal window and again give the command to run. The command is ns space n1.tcl ampersand. So see the condition now. So number of packet drop in terms of CBR is 31 and in terms of TCP is 8. Okay. And you can picture area also you can view the variations with the packets, and drop packet also you can check. So UDP packet started once this particular here when it reaches to 1, my TCP packet starts sending. So let me move the step size. Yeah, see now TCP packet. So you can see the changes here. Yeah. So some of the packets are dropping. Okay. Some of the packets will drop down as I increase the time. See, this is a drop packet. Okay, and here you can see one more thing. For each, see here, for each transmitted node, see there is something coming with the blue color from node 3 to 0, but nothing is coming back from this node 3 to 1. That means we have two different types of protocols. One is connection oriented protocol, another one is connectionless protocol. Connection oriented protocol, in the sense, whatever the data you are transmitted, there is an acknowledgement back from the receiver. Connectionless means it will, like UDP protocol. TCP protocol is connection oriented, UDP is connectionless. In case of TCP protocol, the whatever the in packets you have sent, for each packet it ensures that the acknowledgement will come back. Okay, so now accordingly we have seen what is the statistics. So when I change this bandwidth, N2 to N3 to 1, then the amount of packet dropped is almost, CBR is 31 and TCP is 8. So now we will see another one more result, so that I can conclude in what way it is executing, and I will command this NAM file, because no need to check every time NAM file, that doesn't have any meaning over there. So I will change this one to 0.5. Okay, then save. Then I will go to terminal window. Then I will give the execution command. See, the number of CBR packet dropped is 55 and number of TCP packet dropped is 18. So now you can see all these three results. This and then this one. So what I have done here, I have just keep on decreases, like as the bandwidth increases for some particular transmission, the amount of packet drop decreases. Okay, so here the bandwidth I have given something like 0.5 MB, hence packet drop is more. Here I have given the bandwidth in terms of 1 MB, hence packet drop is decreased, and here the bandwidth is same for all the duplex link, hence there is no packet drop. Okay, so here I can conclude that for any transmission, as the bandwidth of the duplex link increases, the packet drop, the amount of packet drop, either it may be CBR or TCP, the amount of packet drop decreases. Okay, so this is my first program. I hope the concept is clear. So we'll see in next session with respect to second program. Thank you everyone.